Welcome back, guys. Thank you very much for staying with Tenfold Live, a show that is proudly brought to you with lots of love by Liberty. A special shout out goes out to Liberty for sponsoring our program. Another special shout out goes out to you for joining us. And remember, if you know a lot of people who can benefit from what we're doing, go to your socials and let them know that they're missing on the opportunity to multiply the content coverage tenfold and beyond. And they should definitely join this program. We are busy with mathematics. It's a revision. We're taking any and every question, whether from paper 1 or paper 2 that you're working with. Let us know. We will definitely help you to understand how do you unearth that. We are behind the concept. We want you to understand. The questions are going to change all the time, but the concept will always be there. You just need to know, what do you do when they're asking this? What do you do when they're asking this? What do they want when they say this? So once you keep that in mind, you'll never go wrong. We know that paper 2 keeps serving flames. A lot of flames, people have been burned. A lot when it comes to mathematics paper 2. We really want you guys to understand that paper 2 is not difficult. Just send us questions through. If you're struggling with them, we'll help you to understand how to work with them. One person who did exactly that is Vuledzani. Let's go check Vuledzani's question. It's an awesome question that is based on partly analytical geometry and partly algebra. So let's just see what is going on. It says to us, if you're given x minus 2 squared plus y squared equals to 25 is an equation of a circle, x plus 3 minus 3y equals to 0 is an equation of a straight line, the graphs of the circle and the line intersect at a point A and B. Determine, showing all calculations, the coordinates of the points A and B. So we are being asked once more, in this case, to find the coordinates of the points of intersection of two graphs. Now, it doesn't even have to be analytical geometry anywhere in mathematics. If you want to find where two graphs intersect each other, it is a situation of simultaneous equations. That's the concept that is being tested. Are you able to solve two equations simultaneously? You should know at a point of intersection, those things are equal, or those graphs in this case are equal, and you've got to solve them simultaneously. So let's have fun. All right, so there's a circle. I don't know how the circle looks, all right? The examiner did not draw it for us. So we're just going to put our own circle, just so that this looks a bit different and better for you. Remember, it's very difficult for you to work with things that you don't see, right? So always try to make sure that you draw these things so that you can see how they look. And a straight line is going to be like that. So apparently these two guys meet each other at some random point A and another point B. So I'll say this is A and that is B. We are interested in the coordinates of A, and we also want to find out what the coordinates of B are. Point of intersection, graphs are equal. All right, so now what I'm going to do is I'll first of all take the first one. It is x minus 2 with a square plus y squared equals to 25, all right? This is my equation 1. And then there's another one, the straight line. So I want to take the easier one, the simpler one, which is a straight line. The straight line is x plus 3 minus 3y equals to 0. This is going to be equation 2. So let's try and make something the subject of the formula in equation 2. You take 3y to the other side. You've got x plus 3 is 3y. When you add 3, 1 on both sides of the equation, you divide every 1 by 3. You're going to get a third of x plus 1 is y. And this can be called equation 3. Now that I've got equation 3, I'm going to just sub equation 3 everywhere where I see y in equation 1. So my y, where I see y, I'm going to replace it with 1 over 3x plus 1. And there's y right there. So I'm going to change that and call it 1 over 3x plus 1. That's basically what I'm going to do now. So we've got x minus 2. Okay, let me just narrate that. Sub 3, you don't need to say this, by the way, into equation 1. Okay, and then let's just see what is going to happen. Equation 1 starts with x minus 2. There's my x minus 2 with a square. We are adding it with y squared. But what is my y? We just said y is going to be 1 over 3x plus 1 with a square is equals 25. All right, I just replaced my y with 1 over 3x plus 1. So from here, beautiful people, it's just a matter of performing your basic algebraic skills. Do you know how to square a binomial? I bet you do, because you watched Tenfold Live. So you square the first term, you get x squared. You multiply the product of 2 and x is negative 2x. You double that. It becomes negative 4x. You square negative 2, you get a 4. That's basically how you square binomial. Did you see that? If you didn't, let's repeat it. You want to square 1 over 3. I'm on the second one now. I'm on the second one. Square 1 over 3x is going to give you 1 over 9x squared. and then you multiply 1 over 3x and 1, you're going to get 1 over 3, then you double that. It becomes 2 over 3x, and then you square the last one. It is a 1, and the answer is just simply equal to 25. Okay, from here, we group what we call friends, aka like terms, not that aka, this aka, right? So we're going to have to just find like terms. Who are like terms here? So x squared is friends with 1 over 9 x squared. If you don't know how to add them, your calculator is an instrument, not a monument, so you people should use it. But 1 plus 1 over 9 is as good as 9 over 9 plus 1 over 9, which is going to give you 10 over 9x squared. And then now the difference between 4x, now I'm here, I'm on 4x, negative 4x, and positive 2 over 3x. Those are also like terms. If you add them, you're going to get negative 10 over 3x, okay? Because 4 can be written as negative 12 over 3, and you're adding that with 2 over 3. So that's going to give you a denominator of 3. Negative 12 plus 2 will give you negative 10. So that's why the answer to that will just be minus 10 over 3 with an x. All right, then the constants, which ones are the constants? Well, we've got 4 as the first one. We've got 1 as the one that you also need here. We're going to subtract 25 also. That's like 5 minus 25, which leaves us with an answer of negative 20, and this is equal to 0. So you've got it in quadratic format. You can factorize from here if you are a legend. But if you don't want to confuse yourself, you just multiply everyone by 9. So multiply the entire equation by 9. Just say times 9 to undo the division by 9. I want to undo division by 9, so I multiply everything by 9. 9 times 10 over 9 just leaves us with 10x squared. 9 times 10 over 3, the 3 from the 9 will cancel the 3 on the denominator. I'll have 3 times 10, which is going to give me minus 30x. The product of 9 and 2 is 18. That is going to have a 0 shading along it. So this is basically what you end up with. All right, cool. So now I think 10 can go in all these terms. Remember, 9 times 0 also, you're multiplying 9 and 0, which amounts to 0. So no big deal. So divide everybody by 10. I'm ending up with x squared minus 3x, and then this is going to be 18 equals to 0. You then factorize what you're looking at. Remember, if you can't factorize, it's not a shame to use a quadratic formula. It's there for a reason, okay? Factors of 18, I can get 18 if I multiply 6 and 3. The beauty about that is when I subtract them, they'll give me back my 3. The bigger number copies the sign of the middle term. This one will need to be positive in this case because I need negative times positive to get negative 18. Therefore, these graphs will intersect when x is 6 or when x is negative 3. So that's basically what I'm ending up with. Right. We want the points, the coordinate of the point of intersection. I only have x's. How do I find the corresponding y values? Just go back and substitute this x where you have equation 3. You can use any one of them, by the way. But equation 3 is the one with more juice. Why? Because already y is the subject of the formula. So this here is my guy. Y is already the subject, so I like that one. You could have taken 1, 2, or 3. Any one of them will assist you to find the corresponding y value if you replace your x with the answers that you found. But I like the third one. Why? Because y is already the subject. A third of x plus 1. So y is a third of x plus 1. It is a third of 6 plus 1. A third of 6 is 2. Okay? Plus 1. It gives us a y value of 3. Or y is a third of x plus 1. It is a third of negative 3 plus 1. That's going to give you negative 1 plus 1, which is nothing. Therefore, these things will intersect when x is 6 and y is 3. And they also intersect when x is negative 3 and y is 0. Awesome stuff. I hope you guys can see what is going on. So that's just a fancy way of asking you to do simultaneous equation. They're not explicitly putting it out there by saying solve these two equations simultaneously. They want you to find the point of intersection. You should know all the time at the point of intersection, graphs are equal. Right. Now let's continue to the second part of this question. It's one of the sections that trouble grade 12s a lot. It troubles grade 12s a lot. They're saying to us here, show that the roots of the equation x plus m into x plus n equals to 3p squared are real for all values of n, p, and q. Now, let's just analyze that question and discuss the key words here. First of all, you need to show that the roots are real. Okay? Where do we get the roots of any quadratic equation? The roots of any quadratic equation, they come from the quadratic formula. So you should know, we just discussed it in the previous question. This is why it's important for us to keep touching on all these concepts when we're doing these kinds of things, so that we don't assume that you guys know too much. All right. Now, this is the formula we use for finding the roots of a quadratic. The roots are the answers, the solutions you get when you factorize a quadratic. So now these roots are always affected by what comes under the square root sign. If the number under the square root sign is a negative, you will not get any roots, because the square root of a negative is non-real. Okay? It's non-real. But if that number inside the square root sign becomes a 0, you're going to get two equal numbers, because when you're adding, when you do your plus minus, negative b plus 0 versus negative b minus 0, it's not changing anything. When you're adding 0 or when you're subtracting 0, there's no difference in what you're going to get at the end of the day. So that's what is very important for you to keep in mind. You can get negative b plus minus the square root of something that is negative over 2a. I promise you, in that case, you will not get a solution from that, because the square root of a negative is non-real. Or you can get negative b plus minus the square root of 0 over 2a. Now, adding a 0 and subtracting a 0 is not changing anything, so you're going to get two equal roots. You're going to get two roots that are equal. Now, the only time you'll get different roots is if the number inside the square root sign is a positive value, okay? This is the story of the nature of roots. Very important for you to keep in mind. So the examiner says we need to show that the answer that you're going to get from this particular quadratic, the roots, are always going to be real for all real values of n, m, and p. So our job is just to show that b squared minus 4ac will come out positive. That's all that we need to do. Okay? Let's do that. Let's do exactly that. All right, let's do that. Right, the quadratic was given to us as x plus m, okay, into x plus n equals to 3p squared. We're talking nature of roots. So we need to find delta, which is equal to b squared minus 4ac. We've got to figure out the discriminant and check whether it's positive, negative, or 0. Now, you can't find the discriminant if you don't put your quadratic in standard form. So we need it to be in the form ax squared plus bx plus c, so that we can be able to see what a, b, and c are, and then we can work out our discriminant. Basic multiplication, you're going to get x squared plus xn plus xm plus mn. Okay, when you multiply m and n, you're going to get an answer of 3 times p squared on your right-hand side. Okay, this is not yet in standard form. X squared is x squared plus. Now, in these two, and all this is going to be our c, right? So then we're going to just simply go and work out our discriminant, which is b squared minus 4ac. So delta is b squared. There's my b, which is m plus n squared minus 4. My a is 1, and my c is mn minus 3p squared. Okay, great stuff. So that's basically what I'm ending up with here, and we are happy to all see this, because it then means that we can simplify this and prove that it's going to always be positive for any value of m, n, or p. So I don't want to touch the first one that you see on the left. 4 times 1 is 4, okay, and then negative 4 times mn is going to be negative 4mn, negative 4 times what you have at the end is going to be positive 12, okay, positive 12p squared, all right? Now, what you're looking at here, which is mn with a square, can be factorized. What would it be if you break the brackets by not factorization? I mean by just doing 2 brackets and multiplying them out. You'll get m squared plus m times n, which you're going to need to double, which is going to be 2mn, and then you're going to get n squared, okay, minus 4mn plus 12p squared. Okay, these guys are like terms. You're now having m squared. This is going to be minus 2mn when you subtract 2mn with 4mn, and then you get n squared here plus 12p squared. What is this? This is a beautiful trinomial, okay, which can be found by having m minus n squared, okay, plus 12p squared. Now, you'll agree with me that no matter what n and m is, anything squared is always positive. So this thing is squared. And then anything squared is always positive. All right? This here is also squared. It's positive 12. So it will also be positive. Therefore, the roots, no matter what p is, no matter what m is, no matter what n is, the roots will always be real for all real values of what? Of m, n, as well as p. Absolutely nice question. Not at all difficult. What matters in this particular question was just a matter of getting you to understand that when you are dealing with a situation like this and somebody's asking you to prove that roots are real or non-real, you're always going to check for b squared minus 4ac. If it's negative, roots are non-real. If it's 0, you get 2 equal roots. If it's positive, then you're going to get roots that are always real for all real values of any variable that you could be playing around with. Absolutely awesome.